We'll see if it's working. One of you may try and click the link that I've sent out for the YouTube to make sure. One of the organizers, not the panelists, don't need to worry about this.
Going live.
We'll see if it's working. Oh, one of you may try and click the link that I've sent out for the YouTube.
All right.
And that worked through the link that everybody that was like attached to a registration email or whatever.
This is super meta, like watching a YouTube of a YouTube, you know.
Yeah, totally.
Matrix.
Because I'm just gonna send the link out again to all the registered people.
It works.
It works. Oh, the link works.
The link works. Yeah.
Excellent. Okay. Nice. So what I'm going to do now is I'll share my, are we all ready to like really go live? Excellent. So I'm going to turn my video off for now. And then I will share my screen with what we're going to start with. Sound good? And we'll open it up. All right. Here we go, everybody.
Sounds good. And Francis, just so you know, you are, by being organized, you're not going to get out of answering some questions for your own research. So.
Oh, that sounds good. Gary, did you have a question, Gary?
Yeah, when we share a screen, do you want us to share our whole screen or the actual app, like the PowerPoint app? So you know when you go to share screen, you get an option of which screen to share?
Yes. 1 second. Yes, so I would just, I mean, whatever you're comfortable with, but it's probably easier just to do your PowerPoint app. So then you don't see anything else on your desktop. But yeah, okay. That's up to you. Okay, so let's see. Now I have to figure out how I'm gonna do mine. So share screen, PowerPoint. Share. Okay, and then what does everyone see in this view?
I see your presenter mode.
Crap. Okay.
So I know how to do this. Yeah. It's
how?
If you go back to it. I just had to do this.
Okay. Did that work? Did that fix it?
Oh yeah, that worked.
Okay. Oh no, though. How do I? But now it's bad, right?
Right, now it's bad.
Okay. How do you do this?
Okay. So when you go into the presentation, if you see the presentation instead of the presenter mode, in one of the corners you'll see like a little pin, like kind of icon when you hover over it. And for me, it's my bottom left corner, but it might be your top left.
The little pen. Yes, I see it.
So then click on that, and there should be like swap displays.
Okay. My problem is when I do this, I can't see Zoom at all, is the issue. So,
oh, yeah, that's true. Yeah, you won't be able to see Zoom.
Here, I know what I'll do. I have a very quick pivot here. We'll do it on a Google slide.
Okay.
I know that works.
But yeah, so I don't know if the rest of you guys have encountered this problem yet, but I did just the other day where I shared my PowerPoint slide, but it looked like a presenter mode for other people.
So so what I do for teaching is then when I share my screen, I mean, I could try it now.
Yeah, right now, yeah.
Let me bring up my PowerPoint. So then if I share screen, let me see screen 3. Oh, actually, I'm glad I'm trying this because it's not sharing the right thing. How about that?
Yeah, it's
there we go. Share, and then you can see. Is that working for you guys? Maybe not, because
no, it's not the presentation yet.
You're not seeing the presentation?
No.
Oh, that is odd, actually.
So I think if you go to the slideshow,
Oh, I see what happened. It put me on, here I am like thinking I'm gonna have the answer and it went to the other screen. Here we go. Let me try this again.
Also, if we need, Francis, if you have got this working, maybe we in that email thread, we can all send that slide to you and you can just cycle through if that works.
yeah, that's true.
But this slide looks like it works, but if we need to do that.
It works, yeah.
Yeah. All right, that's perfect, Jen.
Okay.
Oh
So
wait, I
maybe-
didn't see it. Oh, I know why. Never mind. You're fine. You're fine. I didn't see
Okay,
it.
so can we do the other folks while we're just doing this? So yeah, Gary, can you try and share your slide?
Yes.
Yeah, that's perfect. That's awesome. Okay. Stephanie, can you try and share yours? Yeah, I think so. Yeah, it's a little funky, but that works.
It'll work.
Yeah, that looks good. That looks good.
I think I'm only seeing it on part of the screen. Maybe I need to, is that better?
Yes.
There,
okay.
that's it. Yep.
Okay.
Okay, great.
The YouTube stream is a little lagged, just so everyone knows.
Yeah, that will just, I think that's just, we have to
Okay,
live with
yeah.
that one. Yeah, but thank you for letting us know.
All right, Luke, can you share your slide?
Did that work?
No.
I see it. It's just not in presentation mode.
There we go. Yeah,
we
that's good.
Cool.
Okay, so this is good.
That's
That's better.
good. That's good.
Okay. All right. So with that, are we now ready? Because then now I'll open it up for folks in 1 second. So does everyone see that?
Yes.
Yes.
Oh
Mhm.
no, but now I've lost my ability to, oh, here we go. Okay. Hi, everybody. We are now live for our community event. We'll give people a couple more moments to trickle in, and then I'll make some announcements, and then we'll get right to our panelists to make the most of our hour. And just as an announcement while we're waiting, we are also streaming this live on YouTube on our AGU EPSP YouTube channel. So if you have any buddies that get locked out of the Zoom webinar itself, they can join over there. The link that I sent in both the registration email and the reminder email should work. There is maybe like a 3-second delay over on the YouTube, but we will be monitoring that chat for questions as well and passing them back to our panel. But it looks like right now we still have plenty of space here in the Zoom room. All right, so it's 5 o'clock on the dot. So I will get started as people continue to trickle in. So welcome everyone. My name is Claire Mastiller. I'm an assistant professor at Washington University in St. Louis, and I'm one of the organizers for the EPSP Connects team. Before we get started with our community discussion today, hosted by Francis Rangers, a few housekeeping announcements. First, EPSP Connects is looking for volunteers. We hold monthly events, both Q&A panels and science seminars, virtually open to all. And we need a little bit extra help now that the academic year has begun and we've all gotten a little bit busier. Also, if you have an idea for a community discussion like the one we're going to have today, we can help you. We have the technology and the know-how to make it go almost seamlessly. There will certainly be some hiccups here or there, but altogether, we can help out. So if you have any ideas or want to get involved, please email me or Joel Scheingross. Our emails are on the screen here. Also, we have a bunch of other awesome events coming up. This Wednesday, Helen Beeson from ETH Zurich is going to give a science talk on complex system response to external forcings in bedrock rivers. On October 14th, we'll have a Q&A panel on geomorphology and environmental justice with panelists Jose Constantine, Rebecca Lave, and Sokobi Wilson. And then on November 18th, Dr. Josh Galster from Montclair State University will be giving a science talk. To keep up with what we're doing and get more information and registration, please visit our EPSP landing webpage. And so just for today, we are in Zoom webinar mode. So we have turned the chat off and we'll direct everyone to log their questions in the Q&A area. And what's nice about the Q&A is that if you see a question that you also want answered, you can like it, which will bring it to the top of the pile and make it more likely to be seen by our panelists. So do not be afraid to engage in the Q&A and like any question that you think is interesting. And so with that, I am going to turn off my video, mute my mic, and hand it over to Francis and our awesome panel for today. Thanks, guys.
Thanks a lot, Claire. Well, hi, everybody. Thanks so much for joining us. I'm Francis Rangers. I work at the USGS on post-wildfire debris flows in the landslide hazard program. And because of these devastating fires we've seen starting in 2019 in Australia and then more recently in the Western United States, and unfortunately some that you all have maybe experienced personally, we wanted to put together this panel to discuss the effects of wildfire on Earth surface processes. Wildfire is one of those topics that's often mentioned in hydrology and geomorphology classes and textbooks, but it's not typically a marquee topic. It's not one of those major focuses. And there's a good reason for that, that wildfires, it doesn't do direct hydrologic or geomorphic work like a river or a glacier. Instead, wildfire kind of kicks a landscape into a different state by changing soil and surface conditions, and it becomes a catalyst that induces different hydrologic and geomorphic change. So there's a lot of great research on the topic of fire behavior, forest ecology, water chemistry. We're not going to get into that today. Today, we're going to focus on the bread and butter of the AGU EPSP section. We're going to talk about what you would expect after wildfire in terms of changes to geomorphology and surface hydrology. So the intention is just to kind of use this panel to lay out some basics about what we already know about fire effects to surface processes and to get everybody thinking about some important science questions. I'm going to go ahead and introduce the panel here, but I do want to just make sure everybody's aware that there is a special collection of papers that's coming out through AGU. This is called Fire in the Earth System, and that's across multiple AGU journals. So keep an eye out for that if that's something that interests you. So I'm going to go ahead and introduce folks. I'll start with Stephanie Camp. So Stephanie, can you kind of introduce yourself and show your slide?
All right, can you see my slide?
Yeah, sure can.
All right, great. So I am at Colorado State University. I'm a hydrologist. And so we're here in Fort Collins, Colorado. And I got started working on fire because of the 2012 High Park fire, which you can see is right above Fort Collins. So it was right in the watershed that we'd already been studying. And you can, if you can see me here, I was very pregnant at the time and started looking at wildfire. There's Dr. Lee McDonald. We were taking a look at some of the burn. So at that fire, we studied post-fire erosion and the changes over time. We looked at sediment deposition patterns. We looked at thresholds for initiating responses. And so really my experience with fire relates mostly to that fire. This year, the higher elevation of our watershed has burned and merged, in fact, with that other wildfire that happened. And so we are going to see how more snowmelt dominated area responds to fire. So that's just a little bit about me. I'll stop my share.
Thanks, Stephanie. Next, I'd like to introduce Luke McGuire, who's at University of Arizona.
Well, thanks, Francis, for organizing. I'm at in the Department of Geosciences at the University of Arizona down in Tucson. And I really started working on problems related to fire because I was interested in the hazards that it creates, and in particular, post-fire debris flows and flash flooding. I'm a geomorphologist, but I'm really interested not only in how fire affects geomorphic systems, but hydrologic systems as well. And I thought, especially given what we're seeing throughout the Western US and throughout the world in many areas, that I would show a photo of a fire that I worked on starting last year. This is the 2019 Woodbury fire that burned near Phoenix, Arizona. And you might look at this slide and think, well, it doesn't even look like it was burned that bad. There wasn't a lot of fuel on this landscape to begin with. This is the Sonoran Desert. And we don't typically see fire in this ecosystem. And that's something that's becoming more and more common. We're experiencing fire in areas that we haven't historically seen it. And I think that's one of the great things about this session here is that we can talk a little bit about people who've seen fire in different contexts and in different areas. So I'd just like to thank all those involved in organizing this for putting it together. So yeah, that's just a little bit about me.
Oh, thanks so much, Luke. All right, next I'd like to introduce Dr. Jennifer Pierce from Boise State.
Alrighty. Thanks so much for organizing. And Luke, you might have been going off to sample that fire right around GSA last year, from what I recall. So it's good to see an image from that. I'm here at Boise State University. I'm the director of the Earth, Wind, and Fire Lab here, where we study earth, wind, and fire. I first got interested in wildfires actually when I was a teenager in 1988, when the fires from Yellowstone almost burned down our family cabin out the northeast entrance. So that brought wildfire home, both metaphorically and personally. Since then, I worked on my PhD dissertation work here in Idaho on the South Fork Payette River, where I reconstructed longer-term records of wildfire through looking at records in the stratigraphy. And I broke Francis's rule of one slide. So here, just a little glimpse, my different perspective here on the panel is that of time, where I'm looking at past records of fires and geomorphic response, and how both temporal and spatial changes in fire and climate can mark their effect on the landscape. In addition, I also have a student who recently completed his thesis examining the effects of post-fire wind erosion, which is important for many of our rangelands. So again, my main interest is to understand modern to Holocene changes in the relationships among climate, fire, vegetation, and geomorphic response. And also really to be able to effectively communicate this to our communities that are now suffering the effects of fire with our ongoing changes in climate. So it's great to be here on the panel. Thank you.
Oh, thanks a lot. And next I want to introduce Dr. Gary Sheridan, who's at the University of Melbourne. He's going to give us more of an international perspective from Australia.
Thanks, Francis. Can you see my slide okay?
Yeah, that's perfect.
So, yeah, my name's Gary Sheridan, and thanks, Francis, for inviting me along. I'm from the University of Melbourne School of Ecosystem and Forest Sciences. I first got interested in fire and erosion and hydrology back in 2003 when we had a big fire year in southeastern Australia. And we were kind of tasked with looking at the impacts of fire on water quality. And that's kind of been the sort of driving force for quite a while over that time, looking at how fire impacts on both water quality and infrastructure. Our initial work sort of focused around paired catchment studies and really just trying to work out what the total amount of erosion or the effect of fire and erosion rates, so the magnitude of change with fire. And that then sort of developed into trying to understand the processes that were driving erosion events after fire. So we kind of discovered that there were some areas in our landscapes in southeastern Australia that were extremely vulnerable to really high magnitude erosion, and then other areas that had almost no where fire had almost no impact at all. So we embarked on many years of research, and I've got some pictures on the slide here of all our sort of different research techniques, from plots to rainfall simulators to dye studies and small catchment studies, sediment tracing, all kinds of methods to trying to work out how the landscape worked after fire. Probably in the last sort of 5 years, we've sort of shifted our focus to this sort of little symbol in the bottom, or what's represented by this little symbol in the bottom left here. So initially all our work was about the effect of fire on hydrology, so surface hydrology and erosion. And then more recently, we've sort of been looking at sort of feedbacks, how hydrology in turn affects fire. And then we get in this kind of loop where fire is affecting soil properties and erosion, which is affecting soil properties and soil depth, which in turn affects the ecosystems which establish on that soil and the water balance of that location, and feeds back onto the fire frequency. So we get these kind of co-evolution of the fire regime and the sort of geomorphic regime. Yeah, so that's kind of what's keeping us busy at the moment. So I'll leave it there. Thanks, Francis.
Oh, thanks so much. So let's go ahead and start. I'm going to launch into some questions for the panel, and then we'll eventually get to some questions from the audience here. But just for some background, last year in Australia, there were 46 million acres burned. This year so far, as of this morning in the US, we have more than 6 million acres burned. We have, fires throughout the Western US. I'll throw this first question to Stephanie. If you're a grad student or a researcher and say you're researching a critical zone or something in a nearby watershed, and now your watershed is burned, what are some changes to hydrology that you might expect to see in a burned watershed?
Right. So the kinds of changes are going to vary, obviously, depending on the nature of the climate, the nature of the materials that are at the surface, how severe the burn is. So if the burn is particularly severe and it leaves a lot of bare ground, then you can expect quite a bit more surface runoff. So the likelihood of that surface runoff happening will depend on the nature of the climate. So if there's a lot of high intensity input, then you can get a lot of overland flow that will increase peak flow in downstream channels. It might produce quite a bit of erosion and downstream sedimentation. But if you're in a climate where the input is more gentle, so more gentle rain, gradual snowmelt, then you might not see quite as much change in the flow regime. So really, those two factors, whether or not you have quite a bit of bare ground and severe burn, and then how the input interacts with that bare ground, is going to be important in the hydrologic response. Quite frequently, we would see quite a bit of stream flow response to fires. So especially soon after the burn, where streams will respond much more quickly to rainfall input. But if a lot of ground cover remains and the input isn't that intense, then you might not see quite that same sort of large response to fire. Some other factors that might be affected hydrologically would be the dynamics of the input. So how much of that moisture that's coming in gets intercepted. If you're in a snow climate, how much of the snow gets intercepted is going to be particularly important, as well as the change in the radiation exposure of that snow. Because when the burned area loses its vegetation, the snow will be much more exposed to incoming radiation than it would have been otherwise. And the time scale of that response will depend on how long it takes vegetation to get back. And that's really a key in hydrologic response. What conditions set the stage for vegetation to start coming back? To slow down that surface runoff response, you need ground cover. But you can have long-term responses that relate to what kind of vegetation reestablishes over the long term. So for a forest to grow back is going to take quite a while. So there might be some long-term hydrologic effects of the vegetation that results after forests, because the vegetation transpires in different ways.
Thanks a lot. That's a really nice overview. We'll circle back to that a little bit, but so the next topic that I want to get a brief hit on briefly is, this is for Luke. Can you kind of follow up on that, some of those hydrology changes Stephanie was just describing, and talk about the soil changes and how that kind of comes into play with sediment routing?
Yeah, sure. Yeah, I think Stephanie gave a great overview there, and I just want to preface everything that I'm about to say that, you know, like Stephanie mentioned, that a lot depends on the severity of the fire. I was out at the Bighorn Fire, which is near Tucson, and it's a really popular area for recreation. And I ran into a couple of people, and they were asking me, well, why is this hiking trail closed? And I said, oh, well, it's the fire. And they look around and they said, what fire? It burned here? You know? And I said, yeah, you know, we're right in the middle of the burn perimeter right here. And that was because we were in an area that was burned at low severity. And so the first thing you'd want to do is go and check out the burn severity map for your area, and not just your site, but what's it like upstream of your site, because that, you know, you can have runoff generated there, even though it's not local, and that's going to affect what happens in your area. And so in a lot of these moderate to high burn severity sites, you're going to see decreases in ground cover, increases in runoff, and that can change process dominance. So, you know, in areas where you may typically see most of your sediment transport happening through kind of traditional, you know, like grain by grain processes, bed load transport of sediment, instead you might see debris flows or debris floods moving through those same channels. Because of the increases in sediment that you get. And that's not just a result of the increase in runoff, but it's a result of kind of a change in the erodibility, effective erodibility of the soil. And that can be for a number of reasons, but for one, in a lot of areas burned at moderate to high severity, the fine roots near the surface that help to provide some apparent cohesion, that gets removed. And previous studies have shown also that just in general, that exposure to extremely high heat can decrease the entrainment threshold for sediment detachment. So you may see increases in rilling where you're not used to typically seeing that. increases in rain splash driven erosion, again, because there's just no ground cover. And then maybe an increase in the prevalence of mass movements and debris flows in areas where you're used to seeing stream flow.
Thanks a lot. That's a nice overview. So next question's for Jennifer. Can you talk just a little bit about how fire kind of varies across the West, different recurrence intervals, different forest types, how that kind of varies, and what you see in, say, Oregon in terms of response may not be what you would expect, in the Southwest in New Mexico.
Yeah, that's a great question. And even though it would be really nice, and we have to, as scientists, generalize to some extent about post-fire response, really from an ecological standpoint, that's very hard to do. So again, tying this back into what Stephanie and Luke just were saying, the burn severity is a real key component to, and of course the topography, to dictating what kind of a post-fire geomorphic response you're going to get. So then those factors, vegetation, your topography, the type of, even if you're in a forest, the forest type, all the prior climate conditions, the buildup of fuels, all of these dictate the severity of the burn, and then therefore the post-fire response. Tying this into what's happening right now, if you went from recent fires in the sagebrush steppe outside of Reno to fires in the redwoods in Santa Cruz, fires burning along the McKenzie River in dense, usually way too wet to burn forests. All of these different areas have different burn severities and also different amounts of soil and colluvium stored on those landscapes, depending on the time since the prior fire, the bedrock type. Here in Idaho, we have very erodible Idaho batholith granitic rock, which I joke, it'll erode if you look at it wrong. Whereas other places you have very resistant bedrock where it's harder to produce those erosional events. What Luke also kind of referred to earlier was these changes in fuel load, and fuel type, from both changes in climate and changes in invasive species. So I would say that in our wet, moist forests, again, using the McKenzie River, which is burning right now in Oregon and sending smoke and ash to me right here in Boise as we speak, those forests I would have thought of as being much too wet to burn. And you look at the fire return intervals for forests like that, and they're hundreds of years. So in those forests, you have a lot of sediment storage on those hill slopes, and it'll be very interesting to see what happens in those areas. In some of the desert Southwest that Luke was referring to, those environments had been what we call fuel limited, where they lacked the continuous carpet of fuels to produce a severe and connected fire. Now with the introduction of invasive species such as cheatgrass, bufflegrass, those have now provided a continuous carpet of fuel to produce a more continuous high intensity burn. So.
Yeah, that's a good point. That's part of that changing landscape, that fires moving into areas that are kind of unique and haven't seen fire in a while. So I want to get over to Gary and ask, can you kind of expand? You've thought a lot about aspect, radiation, different ecosystems, and even in places you worked in Australia, how the north versus south side of a hill slope can differ quite substantially in terms of their runoff and erosion response. Can you just kind of expand on what people might expect and be looking for, in terms of just local microclimates and how those are different even if it burns on both sides?
Yeah, so I guess just sort of building on the themes from Jennifer in terms of generalizing these processes on all different locations versus sort of honing in on specific things that are going on in particular ecosystems, and also on Luke's comments of the importance of recognizing how processes change. So we have erosion processes with a range of sort of characteristic magnitudes after fire, from sort of inter-rill erosion to rill erosion to channels to debris flows, and these have really large differences in the magnitude of the erosion rates that are associated with them. So when people look around at the impacts of fire in different systems, they report anything from almost no change after fire through to 5 orders of magnitude change, and that's just an enormous range for anyone looking at their landscape and going, what's going to happen after fire? That's not really that helpful, because it's almost like anything can happen. And I guess our experience of this, as you mentioned, was in relation to aspects. So we have looked at erosion rates and the properties of soils on north and south aspects, and so we're sort of down at 37 degrees in the south, and so we get very different sort of radiation loadings on those 2 aspects, and we found that even within a few hectares, one side of the hill slope that was protected and wetter and cooler, had developed a deeper soil, a more productive soil. They tended to, although they became very water repellent after fire, they still had strong soil structure and large macropores, and so the water repellents, which was very strong, wasn't able to enhance runoff, and so we didn't get these big kind of erosion events. Whereas on the other side of the hill, only literally hundreds of meters away, the soil was poorly developed, didn't have that macroporous structure, and so when it became water repellent, it just sheets the water off, and so that then drives these really high magnitude erosion processes like debris flows, and so we're getting this setting up a really contrasting set of different magnitude processes, even in local areas.
Well, and so speaking of debris flows and sediment erosion, Gary, I'll start with you, but anybody can chime in. What are the ways that fire influences water supply? Because obviously, if you have enhanced runoff and you have soils that are easier to move because they don't have some of that structure, what are some of the things that people worry about in terms of water supply, reservoirs, things like that?
I guess just quickly to note our experience, so we started off looking at all those different erosion processes, from sort of channel saturation to inter-rill and rill erosion, and it just turned out that in our part of the world, the debris flow process was just orders of magnitude higher than all the other processes, and so really for us, the prediction of where debris flows might occur and how probable that is, and the loads that they would generate, became the dominant kind of water contamination objective. And then we kind of, almost all the other processes, we just kind of forget about them really from a risk management, risk mapping perspective.
Mm.
So in the other part of the world, in Colorado, we do have more concern about the erosion. In some of our fires, we get large pulses of turbidity in rivers after rainstorms. And so the water supply intakes need to be shut down because the filtration systems can't handle those high turbidity pulses. And there are also concerns with reservoir sedimentation. So that can come from debris flows if they're right next to the reservoir, but also just the really high sediment loads of the tributaries coming into reservoirs.
Mm-hmm.
And I would just add, from a really basic perspective, if you are in a steep forested landscape and you remove all the vegetation, essentially, you've completely cut off that evapotranspiration part of your basic hydrologic cycle. So that has a dramatic influence on the water cycle. And yeah, just to second Gary's observation that, debris flows, you look at these long-term records from background trapping engaging in the absence of fire and debris flows. And debris flows are 3 or more orders of magnitude higher than those background erosion rates. So it really is certainly a game changer.
Yeah, debris flows are such a big deal after fire, and they're so genetically linked because you have that a landscape where it's steep, and all of a sudden you've taken away the vegetation and you've made the soil hydrophobic. So I feel like a lot of people have heard of hydrophobicity, kind of have a sense. Can somebody just kind of chime in, just kind of give a hydrophobicity 101? Like what do people mean when they say hydrophobicity?
Since we're all jumping at once, and I know, Francis, you could give a great definition of that. But hydrophobic is exactly as it sounds, so water repellent. But this, of course, is something that the fire folks talk about all the time, and many of the folks on this call may have no idea what we're talking about. So following fire, the high temperatures of the fire, along with surface sealing effects of ash and inputs of fine sediments, can dramatically alter the surface of the soil. So what I do with my students is really fun, and you can do it yourself if you have a burn area near you, which many of us do. You go out, and what you can observe is that a couple centimeters below the surface of the soil, you can drop some water droplets on, and they just stay on the surface. Instead of infiltrating, the water stays on the surface because of multiple factors. Again, the high heat from the fire, which can drive some of those volatilized hydrocarbons and waxy surface substances from pine needles and eucalyptus into the soil. Again, along with the surface sealing effect of ash from the fire and those fine particles, limit infiltration. If you've basically created a water repellent barrier there in the soil, you've limited infiltration, you have some fine-grained, you've got material on top of that. All it takes then is a 2-year or less magnitude storm to potentially produce a very large geomorphic response. So that water can't infiltrate, it runs off. As it runs along, it collects more and more sediment, a term called sediment bulking. That sediment can then coalesce into into rills and first order channels and produce debris flows. So that's the short answer. And I know everyone else on this panel has a much longer and more complicated answer with lots of cool math. So,
we'll following on that, I'm going to direct this specifically to Luke. So, there are places, Luke, that you've seen, in California where there's just all of the vegetation is gone. I mean, there is not a stick left. There's also places where you've worked that are forests, and there is a lot of the shrubs and small things are gone, but there's still tree trunks, things like that. What's the effect on runoff of just changing the surface roughness in steep places?
Yeah, good question. I think it can, it varies from place to place, depending on essentially what your pre-fire condition is. But I think it can be huge. I think that that soil water repellency gets a lot of attention, and rightfully so. But if you decrease hydraulic roughness by a substantial margin, like you often do in many post-fire areas that are burned at moderate or high severity, then you're really changing the transit time of water through the system, and that can have an effect at larger scales on your runoff coefficients and your effective infiltration rates. And yeah, we've seen that in several areas. Oftentimes the result of a fire is an effective increase in runoff for a given rainstorm, but in some areas you can attribute the bulk of that to soil water repellency or changes, reductions in interception from not having a canopy. But in other areas, you might actually see that the recently burned soils are actually less water repellent than the nearby unburned soils. And you may still see an increase in runoff. And that could be a result of decreases in hydraulic roughness from removing all of that ground cover. And that's, just to build on our discussion of water repellency, that it's not just, you don't see that just in burned areas. You do see that in unburned areas. And whether or not you get increases or decreases in water repellency is complicated. I wish I knew the general answer to that question, but yeah, just wanted to throw that in there along with the rest of this conversation, that in general, I almost have always seen an increase in runoff from burned areas that I've studied, but the reasons for that can vary from site to site.
Yeah, good points. This one's for Gary. You kind of talked about how it's really tricky when you observe burn areas where some areas produce almost the same amount of erosion as an unburned area, and then some places can be up to 5 times more. Can you just kind of get into what people do to typically develop like rainfall thresholds and some of the basics of developing debris flow thresholds or criteria based on rainfall that people use?
Yeah, so our experience kind of followed really the USGS approach that say Sue Cannon and some of those people working on post-fire debris flows initially worked on, looking at rainfall thresholds. So we sort of came up with similar sort of numbers in Southeastern Australia. So the frequency of the rainfall events to generate debris flows is they're very common rainfall events that they were previously thought of as these, in our part of the world, as these freak kind of erosion events. They'd be called freak mudslides and things like that when people saw them and when they impacted on towns and things like that. But we now know that the rainfall thresholds, as Jen mentioned, they're just very common rainfall events that can generate really high magnitude erosion events. So 1 in 2, 1 in 5 year events. So, our approach to try and understand those thresholds was to map the debris flows, so air photos before and after, or just after fire, and then a year later after fire, and then identifying the places where debris flows occurred, and then working out the rainfall intensities that happen in those locations, and taking into account the other kind of landscape factors, trying to identify the frequency of those rainfall events. Unfortunately, some of them have rain gauges next to them, and we're able to kind of establish those trigger thresholds. But I think even if you don't have debris flows in your landscape, identifying when your system can jump across thresholds, so jump across the threshold from not producing runoff to producing runoff, like what rainfall event do you need for that? Jumping across the threshold of, say, interrill erosion to rill erosion, you get another big step up in erosion rate. So if you can work out those kind of thresholds in your system, I think you start to see when your system would be pushed to higher and higher levels of erosion. Yeah,
that makes sense. Kind of identifying parts of the landscape where you see different processes and those magnitudes. So because we have about 20 minutes left, and I just want to we're getting a lot of great questions here coming in from the audience. So I think I'm just going to try and turn to some of these questions, and we'll just take a stab at trying to answer these. So Josh Roaring, he asked, and Josh could very well be on this panel as well as any of us because of all his work with fire. He says, after the 2017 Eagle Creek fire in the Columbia River Gorge, the concern for post-fire debris flows was high, and at least one alert was raised. But there's very little data regarding the applicability of California-style post-fire debris flows in the Pacific Northwest. What can we go out and measure in the near term to better understand the potential for this process in the steep and previously verdant slopes of Oregon and Washington. So yeah, does anybody want to start on that one?
Hi, Josh. I'm so glad you're listening and glad you asked that question. I've actually been really wondering about this right now as these fires are burning in, again, these previously verdant areas. I'd say if it was up to me and I had a bunch of eager grad students, one of the most important things, maybe the most important thing, would be trying to get a handle on changes in infiltration rates on those slopes that you'd want to try to get out there and measure soon. And I guess my question that I don't know the answer to is whether or not those kind of Pacific Northwest soils in an unburned state are pretty fluffy and organic rich and have lots of roots and high infiltration rates. And I'd be very curious to see how much the effects of ash and the fire might have on infiltration rates in those soils. So that would be one thing I'd be quite curious about. I'll turn it over to anyone else.
Yeah, Josh, I guess our experience trying to measure change, again, I would focus on the surface hydrology, so runoff generation, surface runoff generation. But our experience with measuring things at different scales, so from from small scale measurements of hydraulic conductivity of the soil through to rainfall simulator plots, through to permanent plots, in the order of meters, through to small catchments, I've kind of found that the sort of scale dependency of the hydrologic parameters that you can measure is really problematic and been really problematic for us in burn landscapes. So trying to scale up something from a rainfall simulator plot, for example, just didn't work very well for us because of the way runoff infiltration coefficients kind of change with scale. And we found the sort of small sort of headwater catchment, like in the order of half a hectare, was the most useful scale for measuring runoff and erosion to get away from those scale effects.
I would, I totally agree with Jen and Gary. And the other thing that could be really helpful would be some estimates of grain size in the channel. So in thinking about post-fire debris flows, they're often generated by runoff in the first year or two after the fire. And so, of course, the surface hydrology is really important, but then also the size of the sediment that it has to move. And, a lot of what we know from Southern California may not apply as directly in other areas because there's a lot of dry ravel in the transverse ranges of Southern California. And you just fill all of the channels with this really fine hill slope sediment. And there aren't too many other places that I've seen where you have that type of extreme change in grain size in the channels. So just another thing to try to quantify.
One thing, so Kristen Sweeney brings up, she says, echoing Josh's question, can you comment on the potential post-fire processes along the Mackenzie River, given that much of the area is underlain by very young porous lava flows?
Again, I think that's a great question, and that infiltration rates will really be a key to answering that. I just wanted to also, and I'll let other folks jump in there, but Gary's point about a scaling is key, and I just wanted to bring that home in a recent great synthesis paper by Shakespeare, Moody, Martin, and Robichaud. They state, the spatial scales at which critical post-fire processes are investigated it's very hard to scale these events, and so scaling from rills to channels to debris flows to larger areas is a big unanswered challenge, I would say. So for those who are listening, looking for a thesis area, go for it.
Yeah, and I'll say to Kristen's question, you know, I'm really curious about if the young porous lava flows would affect it or not. It may be really important, but if everything is happening in the top 5 to 10 centimeters of soil, it may not matter at all what's underneath. If it's going to be, you know, if it's really about the soil hydrology. But I'm not entirely sure. Here's another good question. Oh, yeah, go ahead.
I was just going to say, I think Jen's point is really key there in terms of what's happening with the infiltration capacity of the soil, because if the soil infiltration capacity is maintained and the water can get into those porous lava flows, then it may not be as big of a hazard as if the soil infiltration capacity decreases a lot, or for some reason the water stays closer to the surface. And if it does stay closer to the surface, you might find out really quickly as the winter comes how, you know, what happens in terms of debris flows.
Yeah, good point. And our friends up in the Northwest know better than anybody that often, you know, that landslides follow fires decades after, you know, 7 to 10 years after. I know those guys are very well aware of that and think about that. Here's a question by Kendra Fallon. In the understanding that low and high severity fires are on the sides of a bell curve of severity, how do you suggest studying the impacts of a mixed severity fire, which is often, in essence, a combination of patches of high severity fire with less severe fire when determining post-fire effects? Mixed severity is often a conundrum for describing effects, but is one of the most common fire regimes in the West.
So relating back to the question of scale, it's really key. You know, if you're interested in a very small domain, then you can just sample the different areas. But to scale that up, you need to understand the mosaic of burn severity and how those severe or moderate patches connect with other severe or moderate patches, and how they might be buffered by low severity patches. I think that's a really important topic for us to understand better.
That's a great question, Kendra, and I know that you're dealing with this in the real world, so appreciate everything you're doing right now, fighting actual fires. Yeah, I would just echo that, and I can't remember if it was Gary or Luke who highlighted the importance of those smooth, continuous burn surfaces in generating sediment pulses. So that again, that's a big factor, which again relates to Stephanie's point about scale. But if you can, in those either severely or less severely burned patches, if you do have smooth continuous runoff paths, those will be what generate your sediment.
Good points. Here's a great question. We got to get this out there to the panel. This is from an anonymous attendee. For the panel, what do you recommend for researchers who have gathered pre-burn survey information that might be useful for post-burn debris flow hazard forecasts after a fire? Soil depth, sediment, grain size, sediment volume, especially if this data is collected but not published yet, but still potentially useful for debris flow hazard forecasts. I mean, I will chime in here and just say, that's great. If you have that information and you're working in a burned watershed, if you can go back out and now measure all that stuff again, you know, as precipitation events come in, because that is exactly the baseline information that we need, and it'd be really useful to know what is the typical grain size of the pre-burn soil, and now how has it changed. You essentially have set up in time a sort of paired watershed. So I don't know if anybody else wants to say anything to that.
One of the metrics we found useful is measuring the depth of. So we have these clay loam, commonly have these clay loam sort of soils where the underlying soil is quite cohesive, and then the surface soil after a fire is effectively a layer of non-cohesive material is generated from the heating of the soil. And we've sort of found that the probability of debris flow is strongly linked to sort of how much of that material is available to be sort of swept off the hill slopes by the enhanced runoff. So if I was going to measure something, I would try and get a handle on how much of that material had been released by the fire, if you have these kind of cohesive soils underneath. If you have other systems that have, erodible material underneath, that may not be so relevant. So it depends on the soil.
Yeah, good point. I have a long question here. So a smattering of publications, this is from Natalie Caller. A smattering of publications have come out over the last few years suggesting that if predicted ahead of time and planned for appropriately, an increase in water yield following a wildfire can be an opportunity for downstream water utilities and resource managers if they increase their storage or if aquifer recharge rates go up. Indigenous communities also speak frequently about the cultural and ecological benefits of fire, natural and prescribed. Has anyone on the panel seen a hydrologic modification from one of these megafires that academia and agencies focus on that can truly be viewed as a quote unquote opportunity? Or does the increased reservoir sedimentation / geomorphic hazard / water quality degradation universally seen after megafires overwhelm any co-benefits?
So I would say that the latter. Usually the hazard risk is quite high, and that poses a big risk to current water supply systems in terms of being able to treat water in the way that is normally done without that excess sedimentation. The effect of fire on water yield can be measurable in some circumstances, but in other conditions, it might not be discernible from the natural variability that you get from year to year on water yield. And so you would need to know that you would definitely have that kind of effect, and that the added water yield, if it is there, comes more gradually, like sort of a gradual rise and fall of the hydrograph, so it can be taken advantage of versus in big storm pulses, which is what often happens after fire.
And I would just add to the great question about, different Native American influences on fire and changes in fire over these longer time periods. We are in a new normal. What we are seeing now in terms of anthropogenic, climate-driven fires is off the charts. And so that, yes, absolutely, there have been interactions with humans and fires over thousands of years time periods. But what we're experiencing now are fires in ecosystems that haven't burned, or certainly haven't burned this severely and extensively for hundreds to in some areas, thousands of years. And really when we're thinking about the effects of the fires that are happening right now on this landscape, this is a new normal. This is a new thing. When I look at these debris flow packets, and I'll see if I can show you some of them very briefly. Again, when you look at these records of erosion over longer time periods, in some areas, what we're seeing now are thick debris flow deposits in areas where there aren't any in the stratigraphic record. And so I think that this is a really important question and an important time to kind of re-examine humans' relationship with fire.
Good point. Yeah, that also kind of hits on this question from Monica Rasmussen. How do you determine what a baseline landscape looks like given Native people's use of fire in shaping the landscape in historic and prehistoric time?
And that again, I think is a great question. And in some areas, for example, here in Idaho, there are many landscapes where the Native American use of fire really didn't affect the fire regimes too much. Whereas there's other areas that are, particularly in areas that are ignition limited, such as the Willamette Valley, typically, then humans certainly did have a large effect on fires. And there's great work by Megan Walsh and Kathy Whitlock and other folks that have Jen Marlin that have reconstructed those longer fire intervals.
Yeah, that's important work. This one, I'm going to direct this towards Luke, I think, but anybody can jump in. From Charlie Luce, what information from existing alluvial fans might be useful for assessing hazards from current fires?
Yeah, good question. I think number one is high quality topographic data. As boring as that sounds, that is extremely important. And with, and one of the big things that we're dealing with now is, we have rainfall thresholds, some existing models that tell us how much rain or what intensity of rain it takes to trigger a flash flood or a debris flow, but we don't have as good a tools for determining where is that going to go. And with these post-fire events, they can be so dynamic that you can see so much change in such a short period of time because of how vulnerable the system is to erosion. And so, it's not at all uncommon to have avulsion events. If you have the initial channel capacity wrong to begin with, then you're just kind of doomed. So I think detailed topographic data, in most cases, 1 meter airborne LiDAR is sufficient. But if you're trying to do hazard analyses with detailed runout maps with a 10-meter data set, it's going to be hard.
Yeah, no, good point. That's huge for modeling. 10-meter DEM is not going to do the job. Okay, so Carolyn Bedwell asks everybody, what are your thoughts about minimizing fire threats to people moving forward in this new fire regime? Like prescribed burning, which is a popular idea in some regions, but is this a good option for all parts of the West, all parts of the world? And so, Carolyn, with the caveat that none of us are real fire ecologists, does anybody want to wildly speculate?
I can comment on Australia. We've got a long history of planned burns or prescribed burns for reducing hazard, and still with that we have a really large debate around, a really polarized debate really. So recent book on prescribed burning in Australia had all the leading authors on fire, prescribed burning and fire hazard, and they're really splitting up into camps in terms of the perceived benefits versus risks of planned burning in Australia. The general sort of synthesis seems to be that the planned burning or the prescribed burning is useful for the sort of more lower severity fires, but when you get to these really high magnitude fires that are really kind of unstoppable regardless of what's been done previously in the forest. And we have forests that are very productive, so they produce new fuels very quickly in the order of years really. And so you need to burn them a lot to reduce the risk of fire. And then when you get these big fires, those burned areas are less effective. So there's a big debate, and I think it's highly variable on where you are as to how effective they are.
And I would just chime in, that was a great answer. I mean, with the recent fire outside of Hood River, jumped the Columbia River, which was a mile wide. I mean, what kind of a fire break would you need if a fire can jump a mile wide river? And so that we're really, again, this is a new normal where the vegetation that is growing on our landscapes germinated in a cooler, wetter time than we're experiencing today. That, trying to thin, to control fire, really we're in a completely different scenario now. So that I think there's certainly areas where that does work. And for folks who are listening, and myself, I live in a fire-prone area, that limiting those ignitions and fuel sources around your home can make a huge difference and can save your life. But can we do that on a large enough scale to reduce fires in the bigger landscape is a great question.
Yeah, that is a really good question. So as we're cruising to a close here, I think we actually just hit 5 o'clock, but I just have one last question. This is pretty easy for all the panelists, and then we can kind of use this to close it out. This is a great one from an anonymous attendee, and they just say, hey, to each panelist, if you can measure one set of new if you could have one set of new post-fire measurements from wildfires this summer, what would you measure? So this is great. Let's just kind of go down the list. And since Jennifer, you're the farthest on my left, so why don't we start with you? We'll just.
This is awesome. So I'll make it short. If I could have hundreds of thousands of dollars, I would, and some great exposure and a bunch of backhoes, I would get as many radiocarbon dates as I could to understand the context of the recent fire within the longer term context and measure a bunch of stratigraphic sections. So that's what I would do.
That's great. All right, Stephanie, what about you?
Well, so this is hopefully not stealing from Luke, but I think really fine resolution topography everywhere. Hopefully more than once. I don't know that that violates the one measurement rule, but repeat, right after the fire season and then later would be excellent.
Absolutely. Gary, if you, what's your dream measurement? If you could just do something.
I guess given our current interest in sort of co-evolution of sort of fire regimes and vegetation and soils, I would measure soil depths in lots of places across complex landscapes to try and relate that to fire regimes and understanding that link, and also looking at stratigraphy to identify a sort of history of debris flows and relating that to climate. If I had a lot of money.
And Luke, how about you? What would you measure?
Oh man, it's so tough. But I agree with Stephanie that, about the topography, but that aside, I think that where pyrogenic carbon ends up after a fire is pretty interesting. And it's one of those things that's always been elusive for me because you just have to be in the right spot at the right time to be able to make the measurements before stuff gets washed away. After one event, if I had a pristine landscape where there was a single pulse of some event somewhere, and then I could go out and measure in a bunch of different places, how much, what's the pyrogenic carbon content in different spots of the landscape, and to be able to quantify that over a large area across multiple scales, I'd like to do that.
And Francis, I want to hear from you about what you would measure.
Yeah, this is easy. I mean, just the baseline thing that I really care about is rainfall and infiltration. So I'm going to head out in the field on Thursday, and I'm going to try and put up some rain gauges and use mini discs to measure infiltration, because if we observe debris flows, knowing what that rainfall was that triggered it, or a flood, knowing what that, the rainfall was that triggered the flood is really important. And so, if anybody sees flows or debris flows, please email me, because I am creating a database that we're using at the USGS to try and improve our debris flow models. Okay, so gosh, I hate to cut this short because this has been really fun and there's so much more to talk about. But I'm going to cut us off here. Some of the folks on this call definitely have a AGU session on wildfire, so make sure to tune in on to that, and I'll turn it back over to Claire.
All right, well, thanks everyone. This was a really awesome panel. It was really informative for me as someone who doesn't deal with wildfire very often. There are still some lingering questions that we might ask the panelists to answer offline. We'll post those responses below the YouTube video, which will stay up on our YouTube page for the time being. But thanks everybody again for joining. And if you want to volunteer, if you have an idea, or if you just want to register for future events, definitely go for it. We look forward to having you in any capacity. And thanks again to Francis and our panelists.
Thanks, everybody.
Bye, everyone.